All right, so let's look at these problems that were submitted. So we've got this 4 over 2 minus 3 times the square root of 12. So we're going to conjugate that. But first, before we conjugate it, we need to simplify it. So this becomes 2 minus 3, and then we've got square root of 4 times square root of 3. That becomes a 2. So what we actually have is 4 over 2 minus 6 times the square root of 3. That's going to make our life a little bit easier. Now we're going to conjugate by this. So times the opposite operation, 2 plus 6 times square root of 3, 2 plus 6 times square root of 3. Okay? So on top, when we do the numerator, I get 4 times 2, that's going to be 8, plus 4 times 6, that's going to be 24 times the square root of 3. That is pretty straightforward. That's done. Okay, that is our numerator. And all I did was this times this, and then this times this. Now the denominator is a little bit more involved, because you have to say 2 times each one of these. So if I say 2 times 2 plus 6 times the square root of 3, I get 4 plus 12 times the square root of 3. And then when I say negative 6 times the square root of 3 times 2 plus 6 times the square root of 3, I get negative 12 times the square root of 3, negative 6 times 2, and then negative 6 times positive 6, that's going to be negative 36, and then square root of 3 times square root of 3 is 3, right? So to resolve this, what I have to do is this would cancel, and then this becomes 4 minus 36 times 3, which would be 108, I do believe. Let me double check that. 3 times 36, yes, okay. So minus 108. So that is going to end up being a negative 104. So this is my denominator. So my numerator is going to be 8 plus 24 times the square root of 3 over negative 104. We know that can't be negative, so we multiply it by negative 1 over negative 1 to get rid of that. So we have a negative 8 minus 24 times the square root of 3 over 104. I know that these are all even numbers, and I know that I can divide them all by 2. Question is, can I divide them all by a bigger even number, like 4? I know these two are divisible by 4. Is this one divisible by 4? And I think it is. I think 26 is the answer here. So if I divide negative 8 by 4, I get negative 2. Negative 24 by 4, I get negative 6 times the square root of 3 over, and then 104 divided by 4 is 26. So I can divide it by another set of 2. So I can divide it by 8. So let me do this again. So I know negative 8 divided by 8 is going to be negative 1. And negative 24 divided by 8 is going to be negative 3 times the square root of 3. And 104 divided by 8, 104 divided by 8 is 13. That should be your answer. And what I'm seeing here is you've taken the negative out and put it on the outside. But what that does is that makes this negative, and this is not negative, this is positive. So while it's technically correct, it's the way it's typed in the system. This should be negative and this should be negative. I do believe that's the correct answer. Let me double check. Yeah, so what you can see here is while this is technically correct, it's not the option that was given to us in the answer key. It's wanting -1 minus 3. However, that's not incorrect. It just means -1 times the numerator, which would change all of this. So I'm going to just adjust it to accept this answer also because it's not wrong. Okay, so next one. Temperature of an ideal gas was held constant. It should be gas. I'll make that correction. Was held constant at 740 kelvins. So temperature can be taken out of the equation. So P1 V1 equals P2 V2. That's going to be our equation. Find the final pressure. If the initial pressure and volume were, so newtons per meter squared, that is the pressure. So we need to put this in the correct format. So this is going to be plus 1, 2, 3, 4. So 4 times 10, -3, plus 4 is 1. So that's to the 1. 4 times 10 to the 1. And then our initial volume is going to be 1, 2, 3, 4. So plus 4 would be 2. So that's going to be 4 times 10 to the second power is equal to, we don't know what the final pressure was, so that is our variable. And then our final volume is, put this in the proper 1, 2, 3, so that's plus 3, be 8 times 10, and -2 plus 3 is 1, so that just remains 1. So that's going to be 16 times 10. 1 plus 2 is 3. Move this up 1. Or actually, we're just going to leave it like it is. And then we've got 8 times 10 times P. So we're going to divide everything by 8 times 10. 8 times 10, right? So then this would cancel. And that would give us the value of P. 16 divided by 8 is 2. And this is 10 to the 1. Bring it up to the top, it becomes a -1. So times 10 to the 2. And that's going to be, the answer is 2 times, and I can't even write it, 2 times 10, and pressure is newtons per meters squared. That is your unit of measure. That's why you're not getting it. I'm not sure if I also did 200, it should be squared, 200 newtons per meter square. I will check and see which one, but both of these should be accepted as correct answers. Let me double check. Yeah, that is the issue. You got the right number. The issue is this is the unit of measure. Notice up here, it gives you the unit of measure for pressure. Pressure is the first one, and this is the pressure, right? So it gives you the unit of measure to use. You didn't have to guess what that would be. All you had to do is duplicate that, and it will take either one of these answers in the system. Okay? Let's look at the next problem. All right, let's look at this one and see what we've got. Okay, so we've got pressure, volume, and temp. So initial pressure, 1, 2, 3, minus 3. So 1 times 10 to the -16. That's pressure. Volume, 1, 2, minus 2. 4 times 10 to the 12th power. And temperature, 4 times 10 to the 3rd power. Okay, is equal to Got to find the final temp. Pressure was 1, 2 minus 2. So 4 times 10 to the third power. And 500 liters. So when you put that in proper form, 5 times 10 squared over T. All right, so 1 times 4, that's 4 times 10, and we've got negative 16 and positive 12, so it's negative 4 over 4 times 10 to the positive 3 equals 20 times 10 to the 5th power over T. All right, so 4 divided by 4 is 1, and that'd be minus 3, so 10 to the negative 7 equals, we're going to multiply both sides by T. So that's going to be T is equal to, I already got an equal sign, hello. This times T is equal to 20 times 10 to the 5th power. So that means we divide both sides by 1 times 10 to the negative 7. 1 times 10 to the negative 7. Cancels. T is equal to 20 divided by 1 is 20 times 10. That becomes a positive 7. That's 12. T is equal to 2 times 10 to the 13th power. And that's temperature. Is it temperature? Yeah, it's temperature, so it's K. So that's correct. That's correct. Let me double check that and see what's going on with that solution. Try refreshing your system, because the answer that is stored in for you is to the second. I don't know why. So just redo that. Exit, go back in, save it for later, reopen it, and then type this back in, because this is correct. This is what I have in the system. And then it's the same thing that you found. So I'm not sure why it's not taking it. So just check it again and see. All right, next problem. I'm going to venture a guess and say that it's the lowercase k. Make that an uppercase K. I haven't solved it yet, so let me, and also you can't have a number that large. It needs to be a ones place in order for that to be correct. So let's look at this and see what's going on. Okay, so initial pressure, that's going to be +1, so 8 times 10 to the 6th power. Atmospheres, 1, 2, 3, 4, minus 4. 5 times 10 to the negative 11. And 1, 2 plus 2. So that's going to be 8 times 10 to the 7th power is equal to final temperature is what we're looking for. So T, 1, 2, 3, 4 minus 4. So 8 times 10 to the 12th power. And 1, 2 minus 2. 1.3 times 10 to the negative 14. Okay, so let's do multiplication in the numerators first. So that's going to be 40 times 10 to the negative 5 over 8 times 10 to the positive 7 equals, let's go ahead and reduce this. 40 divided by 8 is going to be 5 times 10 to the negative 12, because this would be minus 7. All right, so now we've got this fully reduced on this side. Let's do this side. So we've got 8 times 1.3. I think that's going to be 10.4. 8 times 1.3, yeah, 10.4. 10.4 times 10 to the negative 2 over t. Okay, put this in proper. So we add 1. That's going to be 1.04 times 10 to the negative 1 over t. Okay. So this is where we are. The reason I did that is because we went forward 1, so we added 1, right? That's the plus 1. So now we're going to multiply both sides by t. Right? This would cancel. So we're going to divide both sides by this factor. So t is equal to 1.04 times 10 to the negative 1 divided by 5 times 10 to the negative 12. So, all clear, 1.04 divided by 5 is 0.208 times 10 plus 12, so that's going to be 11, right? Bring this back, 1 minus 1. T is equal to 2.08 times 10 to the 10th power in kelvins. So 2.08 times 10. So that's what you've got wrong here. You don't have the decimal place in the right spot. This is not standard notation. Otherwise, this would be correct. And use a capital K. And I think that's all the problems that you requested. If you have any more, please let me know.